All right, students, in your experiment, you might have increased the force on a system by pushing on it harder every test, and you would have seen that the acceleration increased. Now that creates a graph that looks like this with a positive sloping trend. Now, also, you might have increased the mass of your system every trial, and you would have noticed that its acceleration decreased. It would have a lower acceleration every test. Now, these two experiments form the basis behind the famous Newton's second law. Now, Newton's second law, it states that if force increases, acceleration also increases. Conversely, if force decreases, acceleration will decrease. That has a name. This is called a direct relationship. This is a mathematical relationship. If one thing increases, the other thing also increases. If one variable increases, the other variable also increases. Now on this side, if one variable increases, the other variable decreases. That's called an inverse relationship. If one thing increases, the other variable decreases. Now, why do we care? Because Newton put this into a special equation. Acceleration equals force divided by mass. And this shows the different relationships, and I'll show you how. Look at force. It's in the numerator. If I increase this variable, make it a larger value in the numerator, well, this variable on the other side of the equal sign also has to increase. If I get an increase here, I'll get an increase here to make this a mathematically sound equation. So that this equation shows us here that there is a direct relationship. And then with mass, if the mass of your system increases, the acceleration decreases. So this equation is nice because it shows us this inverse relationship. I still don't care, Mr. Riparetti. Why is this so famous? Why is this important? Well, it is important because it helps us make predictions. This is what I mean. You can use this equation, acceleration equals force over mass, and you can push on an object with maybe a force of 4 newtons, and maybe that object is about 2 kilograms of mass. That's how much mass it has. And you just plug in these numbers, 4 into the F, and you're doing a substitution problem here, 2 into the mass, and then you end up with acceleration equals 4 divided by 2, which equals 2. This is an acceleration. That object will accelerate at 2 meters per second squared. So if you had some sort of rocket ship, and you knew that it experienced, 4 newtons of force, and this rocket ship was 2 kilograms, then you could do the math and you could figure out, this thing is going to have an acceleration of 2 meters per second squared, and you can land your dog on the moon or some sort of awesome experiment. Let's put a little helmet on him so he stays alive. But anyways, that's why it's so important. That's Newton's second law.